There you go. This is the fractal nature of screencasting. Okay, so we'll begin. I'm going to do a really quick review of the files that we have in this folder. We have a folder called models where we're going to be putting all of our classes that inherit from Active Record Base. So initially we just have this customer class that is empty. It just inherits from Active Record Base, gets a bunch of database functionality because of that, but doesn't have anything in it initially. And we also have in the root folder a database folder. This is where our SQLite database is, and this is a pre-provided database, so we have a bunch of data to work with to start with. And then there is this ar.rb file, which looks like this. And its job is to load up the Active Record gem, to load up the logger library, which we're going to activate a little bit further down here, and it loads all the models. Right now we just have a single model, so it's going to load that one up. It's going to make a connection to our actual database, and so it makes a connection, SQLite connection to the database in the DB folder. This is just a little fix because we're outside the scope of Rails and this variable needs to be set, otherwise I'll get deprecation errors. And I'm going to uncomment line 19 and 22, and now this is going to make it so that the SQL that gets generated sort of behind the scenes and gets executed, we're going to see that SQL. So it's going to log out that SQL too, and sort of mixed in with the rest of our output so that we'll see what Active Record is doing under the hood. So those are the changes I made as I just uncommented line 19 and 22. Okay. We have this other file that we sort of started with last time. I'm going to recreate what's in that file. So I'm going to start from scratch, and so you can sort of watch me code up what's in that file, and then we'll build a few more as well. So I'm going to call this active record read example.rb. And at the top of this file, I need to load in that ar.rb. And so as long as I can run this single line file, we'll be good to go. Good, no errors, we're happy. So our goal with today's class is to work with this customer class, and we're going to work with it in two ways, 2 out of the 4 ways that we can sort of use with Active Record. And these 4 ways are verbs that fit into the CRUD acronym. And so create, read, update, and delete. Anytime we're working with a application where we have a database in the back end, this is typically what we're doing as a programmer. So whether we're working with Rails or we're working with Power Builder or we're working with some other system that has sort of a data backend, we're typically doing CRUD work. We're typically creating new rows in a database table, reading rows back, either individual rows or collections, updating either individual rows or collections in the backend, or deleting individual rows or collections in the backend. Today we're going to look at the C and the R. We're going to start with the R because I find that's the easiest. And we already have a database that has data in it, so that's why also reading will be a little bit easier. We can just access what's already in the database. So we'll start with read. It's also important to remember that by way of conventions, this customer class here, this customer class, by way of conventions, maps to a customers table in the database. And so when we get rows or we create rows in this database, each row will be a customer object, like capital C customer object, and it'll be in the customers pluralized table. So that's just one of the early conventions that we're working with. Again, we still have an empty class here. I've just added some comments to it, but right now it's empty. When we get to the C portion of the lecture, we're going to actually start adding to this class as well. So let's go and grab our very first thing that we can grab from the database. And I'm not going to try to grab an initial row to begin with. I'm just going to try to grab a count. I want to count the number of rows that are in this database table. So I want to use a customer class to count the rows in the customers table. And so I'm going to create a variable called number of customers, and I'm going to do this, customer.count. And what this should do for me is it should do a select count star from customers. That's the SQL that should be executed. And then I'm going to puts out there are number of customers in my customers table. And I should now be able to run this code and see the output down below. So it tells me here there are 10,676 customers in my customers table. That sounds about right. That's the size I built for this particular database table. And then this is the SQL that we were expecting. Select count star from customers. Select count star from customers. All good. Happy. The next thing I want to do is I want to retrieve an actual customer from this table, and I'm going to get back an object of type customer. And so the first thing I want to retrieve is I want to fetch the first customer in the customers table. And by first I mean the one with the lowest primary key, the one with the sort of the primary key closest to 1. And I'm going to do that by creating a variable called first customer. And I'm going to this customer class and calling .first. So one of the things that Active Record gives us, one of the things that we gain by inheriting from Active Record base is we gain all sorts of class level methods. And so remember, class level methods are methods that we can run on the class itself because classes are objects. In Ruby at least. And so this sort of gets around the chicken and egg problem. I can query the customers table, but I don't need a customer object in order to do so. So I don't have to instantiate an object of type customer in order to do things like count or to fetch a customer. I can call methods on my class, and those will do things for me. So here I called a count method on the class customer, and I got the number of rows. Here I'm calling the first method on customer, which will give me the first customer in my database table. And to look at it, I'm going to say puts first customer. And this is going to call the toString of first customer, which is not going to give us too much information. It's going to just be the type of the data type. So it'll say customer, and then there'll be like a memory address. Or maybe it's an object ID. Nonetheless, it's not going to be too meaningful. It's this. We can see the SQL that was executed. It's now a select customers.star from customers. And then here's how we're getting the first one. We're ordering by the customers.id in ascending order and limiting by 1. So ascending order from lowest from smallest to largest, and then limiting 1, so just getting the smallest ID. If I want to know a bit more about this object, though, this isn't too helpful for me. There's this lovely inspect method that I can call on any object in Ruby, and it's going to let me introspect into the object a little bit and sort of tell me a bit more about it. And this is how a customer looks now. And so what this means is, and I'm going to add a bit more documentation here, by way of the customers table, the columns in this table become properties of my customer objects. So if you can see, I get a whole bunch of getters sort of for free, and I'm going to get a getter called .id, which will give me the primary key. It's going to be a .name. You can see here there's like a name property for this customer. There's going to be a .address, a .city, .country, a .postal code, .email. There's a .province ID. We're going to look at that a bit later on. That's a foreign key. There's a created at and an updated at. All Rails tables have an ID and a created at and updated at. And so all objects that inherit from Active Record Base will always have an ID and a created at and updated at. The ID being the primary key, these being timestamps that tell us when this object was created and when it was updated. The rest of them are also columns in our database, but they're defined by us, so that you could assume that earlier on in this process, I, as the programmer, created this customer table and I gave it a bunch of columns, and here they are. And so I can access all of those things on the object that I've just gone and gathered. So sure, I can puts out the customer.inspect, but I could also puts out the first customer's name is, and then I can go to first customer.name, and they live in the city of first customer.city, period. You can see I just broke this string into two halves and concatenated them together. So I run this code, and we see the first customer's name is Christopher Hartman, and they live in the city of Lac La Biche County. Okay. Notice I'm calling those getters just like they were methods. Again, I haven't defined those methods anywhere here. Active Record has sort of created those getters for me by looking at this customers table and sort of realizing that that's what I would need. So that's the first object. We could, of course, ask it its type, and it should tell us that it's a customer. Except that didn't print anything out. Did I not save that?
Is it taking so long? It's going to be turned out.
The reason it's taking so long, I'm not sure why it's not printing out the word customer. The reason it's taking so long is that there's actually a pretty big startup hit on just loading up Active Record. And so if we look at each one of the queries that are being run, they're all fairly short. 10 milliseconds to count the database, 1 millisecond for this select. And that's really it. There was just two statements that are being, oh, I know. I put instead of puts. The big loading time is this. And so we have this initial hit, but then as many different sort of queries we do after that, they'll all be fairly short. There's the customer for my class. So that's one way to get an actual customer object. Just like we have first, there's also last. So I could say last customer equals customer.last, and I could puts out the last customer's name as well. I could run that. There it is. I can also gather up customers by ID. So if I know a specific ID, for example, I'll look at one of these customers. I think Christopher Hartman there came up with an ID. So I'll go and pinpoint his ID. Here he is, ID 498. So I could just get directly C Hartman by going to find 498. So we can find customer objects by ID, although we do so rarely. And what I mean by doing so rarely is it's very rare that we would have like a hard-coded ID in our code, right? Because that's like a database assigned thing, and if you ever were to like say wipe the database and start from scratch, you can't ever really guarantee what primary keys are assigned to any individual row. So it's going to be quite rare that you ever have a hard-coded ID access. So often for maybe testing purposes, you might have a particular customer you want to get to and you know what their ID is. You could find them with this find. Often when I just am doing test code, I might sort of grab the first or the last customer and work with them just because I have little aliases for first and last. We can also get collections of customers, so like not just one row, but a collection of rows. So if we wanted to find all customers, we might say all customers equals customer.all. And then maybe initially we just print out the size, and it should be the same as when we did this count. So we should be able to do something like puts the size of the customers table is, and all customers.size. And so you can see here, same number. The size of the customers table is 10,676. We might be tempted to think that by requesting all customers that immediately the database is going to do some kind of select star from customers. But if we looked at our code, we'll see that we did that same count query again. And the reason is that Rails is trying to optimize the SQL it writes. So it holds off running the SQL until it knows what part of the data set you actually want to use. So although I've asked for all customers, Rails can see that really all I did with that request was asked its size. So on line 31 here, no SQL is executed. It sort of creates what's called a active record relation. And so if I put out all customers dot class, we're not going to see an array. We'll see a active record relation. And then when we call size on it here, Rails goes, well, yeah, Kyle doesn't actually want me to go gather all 10,000 rows and instantiate 10,000 objects. Kyle just wants the size. And so it gets me the size. Once I start treating this thing like an array, though, then it's going to go and get all of that data for me. So it's really interesting how Rails will sort of hold off on hitting the database, because in web applications, the database tends to be our bottleneck. So Rails really tries to sort of save us from ourselves in terms of expensive queries. But now if I start trying to treat this thing like a array, so customers, let's say position 0.name and all customers at position 1.name. In the debugging output, so here we see our two names. Here we see that we actually did that select customer star from customers. Rails isn't clever enough to know to limit my query though. So notice I'm only using 2 elements of that array, but it is still going and fetching them all. It actually has gone and selected star from customers, and then I'm getting 10,000 objects built up. So that could be a bit of a hit. What if I really only wanted those 2 customers? Well, instead of all, I might say something like, or maybe let's say 5, get a few more customers. First 5 customers, it's going to be customer limit 5. And so that's going to bring back a relation, and I can ask it for its size. And of course, if I've asked for 5, the number should be 5. It wouldn't be maybe if I only had 3 rows in my database. So if I try to do a limit query on a collection where there actually isn't that number of rows in the database, it'll come back as fewer. But in this case, we should see 5 coming back. And we do. And then if I wanted to, I could loop through those 5 rows and print out some information about them. So I could say first 5 customers dot each, and then I'll get rid of this and say do customer puts lives in customer.country. And there's those 5 customers. And you can see by doing this limit clause here, customer.limit5, I now have SQL being generated with a limit clause on it, like that. So it still does the select star from customers. We've now got a limit on it. So we're building up SQL by way of sort of choosing the right method names on these active record classes. That's one way of sort of getting a subset. Another way might be where clauses. So a really common thing we do with SQL is we write a where clause. We'll write, select star from something, where, and then we specify a Boolean that has to do with some of the columns in our database table. So if we could imagine for a moment, here we're printing out customers in their cities. So I'm going to look at some of that output and see some of the names that we've had for cities. So if I run this code and am I not printing out their cities? Oh, it's just the first customer. Well, let's print out all of their cities here. Because I'd like to build a where clause so I can sort of find all customers from a particular city. Okay, so there's a few different cities. I'll pick this one right here, Wetaskiwin. So go down to the bottom. I'm going to better make this variable name in a moment. Customer.where city is that, and then here I'll say customers from Wetaskiwin. Puts there are customers from the city of Wetaskiwin. So that's how we add a where clause. It's a hash that we point to or pass to the where clause. Rails and Ruby are sort of letting me leave out the curly braces, but it is a hash. If I was writing this in the new style hashing syntax, I would pass it like this. And when I run this code, we can see how many customers are in that particular city. There are 9 customers. And I could then work with these customers, printing out information about them, accessing any of their properties that have been mapped from the database. The really powerful aspect of Active Record starts coming in when we can combine these different kinds of methods. So imagine I only wanted the first 5 customers from this city of Wetaskiwin. I could say limit 5, And now I'm going to get a select statement with a where clause and a limit clause on it. So I run my code here. It now tells me there are 5 customers from the city of Wetaskiwin. Not really the truth anymore. There's 9, and I've limited it down to 5. But if we look at the select statement here, you can see it's actually done a fairly complicated query. It sees again that I don't actually use those customers at all. So it's doing a select count, and then it's actually doing like a subquery. So it does this query, and then it counts. So it does this query with a particular where clause on it, and then it counts for how many of those actually return. I can chain all sorts of sort of things on here. So I can have multiple wheres clauses that I chain on, limit clauses. We can even do order clauses. I'm going to do a few more wheres, and then we'll look at some of the other things we can chain on. So customers with, I'm going to say A names, and by this I mean customers whose names begin with the letter A. That would just be a bit too long of a variable, I think, for typing purposes. So customer with A names, and this is going to be customer.where. Now here I've passed in a hash, but for something like a clause where I want sort of all customers whose names begin with a certain thing. Do you guys remember in SQL how we would do sort of matches that are a little fuzzy like that? Wildcard based matches. It's a percent sign, and you have to use it with the like keyword. And so I can pass in hashes, and my hashes can even have more than one key value pair. So I could pass in a hash where I'm specifying a city, and I could also specify, say, a name or a country. But here, I can also pass in a string, and this will just be, if I had been writing SQL, this is what I would write as far, like the portion of the where clause after the word where. So where, the name column, like, and then in quotes, a %. So I can use double quotes inside here because I'm using single quotes for my string itself. And so this is going to give me customers whose names begin with the letter A. And I think I would probably want to limit that because there's probably going to be a few hundred. So I might just limit that to 10. And now I might loop through them. Customers with A names dot each C, put C. Oh, and it should be C dot name for it to actually be somewhat reasonable for us to look at. And there we are. So those are the first 10 customers in our database when ordered by ID whose names begin with the letter A. I could also put an order clause on that. So I could say order by name. So I pass in the name symbol into the order. Now that these things are sort of scrolling off the screen, you'll sometimes see people format their queries that are chained together like this, where you sort of line up the dots. Makes them a lot nicer to read, I find. So here we see we're doing a customer with a where clause, an order clause, and a limit clause. And so now if I run my code, the order of the customers will no longer be the primary keys. We'll now first order all of the customers in the database by name, and then we'll pick the first 10 names. So we're all getting Aarons for all of our names because it's double A Aaron. That's going to be the first customers. Yep.
Is it a mathematical ordering, or is it actually by alphabetical? So like if you were to have 1 in front of one of those... It'll
probably be alphanumeric. So the numbers will sort of come before the letters. Yeah, yeah. I was going to say it'll depend on the database, but it won't. That's something that should be like ANSI SQL. Like all SQL should work in the same kind of way. So the order by clause will, yeah, it should be sort of alphanumerics with the numbers coming first.
Oh, it's just, okay.
Because in the end of the day, right, it's just SQL. So if you think about how would SQL do this, that's really what's happening under the hood is here's the statement that got executed. Select customers from customer, where, there's our where clause, which is coming from here. Order by customers at position name, so that's this right here. And then ascending is the default, and limit 10 comes here. If I wanted the names to be ordered in reverse, how do I do that? There's two ways to do it. One, I can just pass in name at descending as a string. So writing the portion of the order by statement that I would have written were I writing SQL. That's really weird though. Ackland. How is that possibly the last? It actually, this might be just a weird thing. My database table may have, there might be like Unicode characters in my database table. So this might be Jacqueline, but with a funny J, like a J with umlauts on it or something like that. And so when I print it out, it's saying AC, but in the database, it might actually be like a 2-byte character, because there's no way that this is really the, if we ordered things reversed, you know, we should be seeing Z. So I'll have to look into that. I think it's the fact that I've got Unicode weirdness happening in my database table. Interesting, nonetheless. And I think there's another way, instead of just doing that, I think I can still do this for name. And there might be like a reverse order. Might have to look that one up. Yeah, it doesn't quite like that one, but there is a way to reverse the order. I can look that up a bit later for us. Whenever you do need to look this kind of stuff up, you're not going to want to go to Google. Active Record has changed significantly over the years that Rails has been around. And so if you're Googling for information for Active Record information, you have to be very careful that the information you're finding matches the version of Active Record you're using. And because we're now using Rails 4, the majority of information you find is not going to target Active Record 4. So you really want to always refer to Rails guides. And almost everything you need is going to be there anyways. And so for Active Record, there's two main Rails guides that you're going to refer to. There's Active Record Basics, which goes over as a high level sort of what Active Record is and does. And it gives examples for all of the variety of CRUD tasks that we can do. So when we're reading, it gives some information about that. But you can see reads a very short line here. There's also an entire section called Active Record Query Interface, and it's quite long. And so everything you could possibly think of in terms of building SQL by way of Active Record is covered in here. And okay, so how does reverse order work? Oh, that's neat. So I would say name dot reverse order. So order dot reverse order. And again, we get these strange names coming out. And again, I think that's because there's some kind of multi-byte encoding going on that I haven't considered in my database. So I'll remove that for now. There's a lot more to Active Record than what I've shown you, but this is a good place to sort of start. We see that we can do where clauses, we see we can do order clauses, we see that we can do limit clauses, we can chain them, we can have multiple wheres, or we can pass in multiple key value pairs for wheres. Later on, the more you learn about Active Record, the more sort of complex things you can do. So there's ways of joining tables together. There's ways of fetching by way of association. There's different ways of setting up where clauses. You'll find them all in this Active Record query interface. So if we went to just the conditions section, we could see all the different ways of specifying conditions. And so you can specify a where clause where you say some column equals question mark, and then you can provide a variable afterwards of what that question mark represents. And the reason you might do that in Rails is often the data you're searching on is coming from your users by way of the web, and you don't want to just give those users the ability to inject stuff into your SQL. So if this parameter here is coming from the outside world on the web, you don't want to just have it being injected into your where clause, because that opens up sort of a style of vulnerability called SQL injection, where you can inject nasty SQL into what looks like sort of a normal SQL statement, and you could do things like your end users could drop tables or whatnot on your back end, because they could pass in sort of a cleverly crafted string which would first stop the first SQL statement, and then it would be a second SQL statement, and it would run, it would, you know, drop your customer's table or something like that. So we have to be really careful about that. And so what these kind of parameterized queries do is they first check for that kind of hacking. So it's like we don't just interpolate directly in data from the outside world, we allow it to filter in by way of these question marks. So that becomes very important once we start working with Active Record in the context of Rails. Range conditions are really powerful for when working with date. And so here we're assuming that we have a client object, we're doing a where clause, and we're saying where the created at column, and then here is a range. You can see the dot dot in the range. We're saying time.now.midnight minus 1.day. So you can see in Rails, or at least in Active Record, they've monkey patched daytime things onto fixed nums. So this is like 1 day before today at midnight, right up to today at midnight. You know, basically this is show me recently created rows. Any row that's been created since yesterday's midnight. So ranges work really well for things like created at. Subset queries, here's one where I'm saying find rows on this client or a client's table where the order count is either 1, 3, or 5. So that's sort of a more advanced style of a where clause. Those are the main ones. So it's worth it just reading through these two sets of documentation, the Active Record Basics and the query interface, just to see what's possible. You probably won't end up doing everything that's in here within this course, but just to have an overview of what's possible is a nice idea. And I think that's where I will leave it for creation, or sorry, for reading. We've done all of sort of the reads that we need to do for our basics of Active Record. And so if we go back over to here, we can say that read is done. Next up, I want to work with create. Before I go on, is there any, is this working for everybody? If you're playing along or coding along, is it actually doing the right thing?
My virtual machines.
Your virtual machine, yeah, you'll want to get that fixed up fairly soon.
Yeah, I switched over to VMware after class and we get those guides from you.
Oh, sweet. Okay.
So much smoother on VMware.
That's good to hear. I'll have to check it out as well. Okay, so that's reading. Let's do some creation. So we're going to create a whole new file in this same folder. And I'm going to call it Active Record Create example. .rb. And I'm going to open that up inside of Komodo. And again, like the last one, it has to start with a load AR.rb so that I can include my active record library and the correct model and everything. So we're going to look at 3 different ways to create new rows in our database table. But we're now going to have to make a distinction between the rows in our table when they are actually real rows in our table and the data that exists inside of objects that are of type customer. Because you might have an object of type customer that hasn't yet been saved. So you have it, it exists, it has all sorts of properties, but it doesn't yet represent a row in the database until you explicitly tell it to save, at which point the data crosses from sort of what I call object space, active record object space, into the database space. So we'll see sort of that distinction, and we'll have to sort of keep that clear in our head. At what point is this data sort of crossing that barrier and actually being written to the database? And it's different in some of these different methods. So the first one, method 1, this is going to be, we're doing create, and this is going to be adding new rows to the customers table by way of the customer class. So method 1, create a customer object in object space. So I'll create a new variable called new customer, and I will just go to my customer class and create a new object. And if I puts out that new customer and I ask it for its class, it should tell me, here I am a customer of this class, and the class is customer. This hasn't changed anything in my database though. I haven't actually gone and created a new row in my database, and I can prove that to us if I do something like this. Fetch the count from the customers table. So if I say number of customers, sort of the same thing we did last time, and I go to customer.count, and then I puts out at the start of my script, we have number of customers, and then I could take this same code and I can put it at the end. Then I can say at the end of my script. So right now, both of these numbers should be identical, right? I haven't actually created any new rows in my database table. So at the start of my script, we have 10,676 customers. At the end of my script, we have 10,676 customers. Good. So there you go. First sort of warning, just creating a new object of type customer does not actually create a new row in the database. We can now, though, start interacting with this customer object in object space and getting it ready to save to the database. So I could say new customer dot name, and I could assign a name to this customer. And maybe we want to then inspect this customer. So I can say new customer dot inspect. And what we should see is we'll see a customer where almost everything is set to nil, except for the name, which is now set to Kyle Geske. And if we had called inspect right away, say on line 14 here, we would see an object where everything was nil, including the name. And so here is that customer object. And you can see that it has an ID of nil. There's my name that I set, but then the address is nil, the city's nil, the country's nil, as is the postal code, email, province ID, and created and updated at. So when we inspect these objects, we can get a pretty good hint as to whether or not we've saved them to the database yet by looking at the ID and the created at and updated at. If they're all nil, well, then this doesn't represent a row in our database table, right? There is no primary key that's been assigned. There are no timestamps that have yet been written. This is just something that exists in object space. And again, at the beginning of our script and the end of the script, we still have the same bits or the same count for our rows. I'll continue to add extra information here. New customer.address. New customer.city is going to be Winnipeg. New customer.postal code is going to be some postal code. Line those all up for the fun of it. That's probably all I'll provide. But now I want to actually save this customer to the database. So puts out here, inspect the customer before we save. Then I'm going to save the customer. And I'm going to do that by saying new customer.save. And then I'm going to say inspect the customer after we save. We're going to notice two things now when I'm running through this script. One of the things we're going to notice is that these two inspects are going to be different. After we save, the next time we inspect our customer, it will have an ID, and it will have a created at, and it will have an updated at property. The other thing we're going to notice is now the number that we count for the number of rows in our table will actually be different at the beginning of the script than at the end, because we will have added one row. And so here's the output. Initially we had 10,676 customers. When we inspect the customer before we save, we can see here it is. It's got data set for most things. Probably should have set a country as well, just so that it was covered off all my bases. Customer.country equals Canada. But before the save, the ID is nil, as are our timestamps. After the save, here's after the save, we can see now our object has a primary key, and it also has timestamps. Both the created at and updated at are identical, and they're both set to the created at time. So if you ever see a object, an active record object, where the created at and updated at are the same, it means this row has never been modified, right? When it was created, both updated at and created at got set to the same time. If they're still the same time, that row's never changed. And now, at the end of our script, we're now up to 10,677 customers, whereas when we started, we were at 10,676. So we've gone up. And if I run this code again, that number will go up one more time. Now we're sort of, in a way, putting bad data in our database. Every time we run this code, we're creating a new Kyle Geske name in the database table. That's going to be okay for us. That we're okay with the fact that we're sort of making a mess of our data set here. But I will, after I show you a few more methods for creating customers, I will show you how to get around that, how we can sort of prevent the database from accepting repeat customers.
So keep it in kind of that
Yes, so we're going to add all sorts of validations to ensure that our data is good. Okay, so that was method one. Create a new customer object in an object space. We created it with the new method. It's just like any other Ruby object at that point. It only becomes associated with the database table when we call .save, then the actual insert statement is triggered. So if we look at the output here, we can actually see the insert statement that was created for that particular customer. Here it is right here. It's written in that sort of parameterized form. So it says insert into customers. It lists all of the columns that we're working with. And for values, it just lists all those values as question marks. And then there's like this array of arrays where it shows us what each of those values actually is. So it's printing it out in that kind of way, but you can see all the data here. Okay, so let's try another way of creating a customer. So the first way is we created the customer object space just plain out with new. In method 2, we're still going to create a customer object using new, but this time we're going to provide some data with some data to the constructor. So I'm going to create a customer called Wally, customer.new, but this time I'm going to pass that data in at the time of construction. So I'm going to say the name of this customer. Maybe I'll get used to doing new style. The name is Wally Glutton. The email address is wally.glutton@mailinator.com. The address is also going to be 160 Princess Street. And I could, I could specify all of that. I could specify as many of those things as I wanted to. I never specify the ID, and I never specify the created at or the updated at, because those aren't for me to handle. Those are for the database to handle. Again, this isn't creating a new row in my database table. It's simply giving me an object of type customer that I can manipulate. So I could say puts wally.inspect. I could run my code, and we can see that there's that Wally. The data that we passed into the constructor is in there. So the name, the address, the email address. We could now, now that we've sort of preloaded it with some data, we could add other data. So we can say .country just like we did before and set it to Canada. And again, when we want to actually save it, we're going to have to do wally.save. And now that'll save into our database. So not very different from the previous way, other than in the first version we created a completely blank customer and then used our setters to set all the different values. In the second way, we provided some of that data as a hash to new, and then new set it for us. There's also a way to create customers and provide data in one go. So if I want to do method 3, create the object and persist it to the database in one go. Here I'm going to create a Jane object, which will be type customer. And here I'm going to use the word create. And create's going to automatically do a new and a save for us at the same time. And so I have to provide it with some data, otherwise there'll be nothing to save. Jane Smith. Oh, and I'll try to do this new style. Try to break myself of the habit of using those old hashes. Email. Address. We all live at school. City. country, postal code. Just leave that sort of as a dummy bit. And now I don't have to call .save. And if I call Jane.inspect, we're going to see right away that the Jane object has an ID on it, and that the Jane object has a created at and updated at on it as well. There it is. So create just does what new and save does, but it does it all at once. So if you have all your data up front, you might as well use that style for creation. And this little script here where it says the end, I'm going to put that still at the end. And I'll just label that count the rows after the script. Or after we have created some new customers. As I said, every time we run this, our table is going to grow in size. So I run it now. In my last line of code, I'll see how large my customers table is. 10,688. If I run it again, it's going to be 10,691, etc. I'm adding 3 customers every time. So what if I wanted to validate against some of this data? What if I wanted to validate that I only want to permit customers with unique email addresses? Like I don't want to probably do a uniqueness on the name because people can share names, right? There's lots of John Smiths or Adam Smiths in the world. But email should be unique, right? And so if I go into my customer class, I can add validations, and I typically put them up at the top. I'm going to say validates that the email address, that the uniqueness is true. Oh, and again, breaking myself of the habit of using old style hashes like that. The last time we ran the code, there was 10,691 entries in the database table. If I run it again, at the end of the code, there should be the same number. And if I run it again, still the same number. I'm no longer adding new customers to my database table. The reason is that I already have customers that are in the table with those email addresses, so this validation is actually preventing them from being added. I don't see any errors in my code though, so if I look in my code, or my code output at least, we won't see any errors triggered. We will see that each time I went to save them, Rails actually does like a select where it checks to see if that email address is in the database table. So by having this validation on an email address, now every time I save a row, I also have to, Rails also triggers a select where it searches through the database table, checks to see if the email address I'm about to add is there. If it is there, then it doesn't actually try to save the new row. These data validations I can use, there's all sorts of validations I can add. If we go to look at Rails guides, there's a whole validation guide which talks about all the different things that we can validate on saving and updating. So validations are run anytime we go to save or anytime we go to update a row. We can trigger them when we actually call a save or a create, but we can also call .valid ? On any object, and it will tell us true or false. Does it pass validations or not? And if we were to look here at, for example, the save on Wally, What's actually going to happen is that now that we have validations in place, save is going to return a Boolean. If it returns true, it means the save worked, meaning validations passed. If it returns false, it means the save did not work. So if I say if wally.save, then I'm puts out, we have saved the Wally customer to the database. We should never see this string now because Wally should never be saved because we already have a customer with that email address. Else, it returned false, meaning we cannot save this object due to validations. So if I run this code, if I scroll up to where that was triggered, it tells me we cannot save this object due to validations. And so we can test to see. We could also have test ahead of time. We could have done wally.valid ? Same thing's going to happen this time, although it's not actually going to try to save it. It's just going to try to test it. And it still says the same thing, we cannot save this object. Put this back to save. We could add more validations, so I could have a validation where, let's say at a minimum for my customer, I want to ensure that a customer has both a name and an email address. Everything else can be added, say, at a later date, but I want to make sure that all customers at a minimum have both a name and an email address. So I might have a validates line here that says the name, that the presence is true. And then I might also want to add a presence true here. So here's the thing that I am validating, and then in this case I have two validations on email, and for the name column I have a single validation, meaning it has to be present. We can even see which validations fail. So I've got in my code already that if Wally doesn't save, we print out we cannot save this object. Well, I could even now inspect the object to see why it didn't save. So I could do something along the lines of like Wally dot, there's going to be an errors, and I can even look further into the messages that were triggered on that error and then loop through each one of them. And I'm going to get out two things. A column, meaning which column in my database table caused the error, or which property wasn't correctly set. And then each column could have potentially one or more errors associated with it. So inside of this loop, I have to further loop through those errors to get each error. And then I can put out the column property and the error question. So I'm looping through the error messages, which column triggered the error, what the errors actually were, then for each of those errors looping through them, and it should tell me in words what caused my validations to fail. So if I run this now, it says the email property has already been taken. If, for example, when I made Wally Glutton here, I left out the name, now there's going to be two validations that fail. And so when I loop through the collection of error messages and errors, it'll show me both of them. The email property has already been taken, the name property can't be blank. So it's going through doing all the validations for me. When we hit Rails, we don't actually have to manually do this. there's a special helper that helps us build forms for data entry, and within that helper we can just do like basically a command which just says list the errors, and what it'll do is it'll spit out all of the errors in properly formatted HTML for us, so we don't even have to do any of this extra work. We just say Rails, output the list of errors for us, and Rails will do that. And I think that's really all we need to see here. Is I should still be able to add new rows to my table. I just haven't been because I already have these in my database, but I should be able to make, say, a brand new test user or test customer. Customer.create, and I just have to make sure it has a name and an email address. And that should make it so that our count increases 1 from the top to the bottom. So we'll do 2 counts as usual. We'll have this initial count. We'll have this secondary count. And now that I have one valid customer in here where they have a unique email address and they have at least an email and a name, should save it. $10,692 versus 10,691. So that worked. Here's the insert statement creating that particular customer. Here's the select statement that was executed when we tested to see if that customer's email address was actually in the database table already. And now if I ran my code yet one more time, now all 4 of the customers that I try to save will not be saved because this now exists in my database, so the email is no longer unique. So the next time I run this code, we'll still have 10,692 entries in the database table. There we are. So validations are hugely important and powerful in Rails. We define them in this kind of declarative syntax where we just sort of define what it is to be a valid entry, and then we don't have to write a whole bunch of test code with ifs and elses and whatnot to test our data. Rails does all that testing for us. So we just define what it is to be a valid entry, and then we let Rails actually perform the validations for us. You can pair these. These are not sort of like database constraints. So it is possible it's still possible for bad data to get into our database if someone was just writing to our database or doing it outside the scope of our Rails project. And so often programmers will also add constraints at a database level. So when you sort of create a table, you can actually do these kind of data integrity things in SQL. And so sometimes Rails programmers will have both. They'll have database constraints in at the database level and then validations at the code level. And they're both serving to ensure that our data is staying valid and that we're not letting any invalid data into the database. If we look at all the different types of validations that are available in the Active Record Validations Guide, it sort of shows a big list of all the different validations that are possible. We've seen presence and we've seen uniqueness. There's also validations like absence. Numericality is interesting. And so here's an example of numericality. We have this player class upon which we say that the points column, that the numericality has to be true, so it has to be a number. But in this case, it could be either a floating point number or a fixed num. But then this one here, we're saying validates games played. We're saying numericality. Instead of just saying numericality true, we have sort of a nested hash, which says only integer true. And so now this column must not only be a number, but it must be a whole number. Otherwise, validations would fail. There is the length property, which is quite nice. So where's length here? Validates name, length, and with length you can have a minimum length, a maximum length, a range in which this thing is valid, or an exact length where the length is 6. Those are sort of handy. Inclusion gives us a way of doing almost like an enumeration. So here we're saying validates that the size is included in the list, small, medium, or large. So if someone tried to save something other than the word small, medium, or large into the size property, validations would fail. And this is also showing an example of the fact that for any given validation, we can also write our own custom error messages. So Rails has default error messages, and we've sort of seen a few of those when we, what's the wrong Komodo? We saw a few of those when we ran through the code, but for each one of the validations, we can sort of write our own custom output for how we wish to talk about something being invalid.
That value variable was, I guess, declared somewhere else in the code.
It's sort of it's like a special thing, right? So it's going to be the value that the user tried to use.
So it'll be defined somewhere else in the code.
Yeah, somewhere else, not in our code, but in Active Record.
Oh.
So it doesn't exist anywhere in our code.
Oh, okay.
Yeah, so it's
something that we can access through Active Record.
You got it. And it just means the most recent, the thing that the person tried to save in. So if I tried to save in like larger into this size property, it would say larger is not a valid size. What else do we have in terms of sort of well-used validators? Confirmation is a neat one. That one gives you the ability to confirm that, say, 2 different properties match. It's often used for like when you set up users and you take in a password and then you make them type in their password twice. So it's not like you really have 2 columns in your database table, one for the first password and one for the second password, but you want to confirm that the data that you're getting from the user, that the 2 things match. So we use confirmation for that. Format is a nice general purpose one that takes in a regular expression. And so say, for example, for my postal code, I wanted to always to ensure that valid Canadian postal codes, then I could say, well, the format is, and I could write out a postal code regular expression that says it must be in the format of like letter, number, letter, number, letter, number, with an optional space in the middle, and then Rails would ensure that all postal codes that get entered are in that format before it allows them to be saved into the database. So lots of really helpful validations, and if none of those sort of suit your fancy or suit the particular case that you're working on, you can write custom validators, which are just Ruby methods that will be run against your data, and you can define those to be anything you want as long as at the end of the day they return either true or false. So if you have a really complex validation scenario that you need to set up, custom validators allow you just to write a chunk of Ruby code that would validate or invalidate a particular column in the database table. And I think that brings us to the end of create. And so we've done our work with reading, we've done our work with creation, so I can say done here. And then next class we'll continue on with update and delete. Update is sort of like a special case in a sense on reading sort of mixed with creation. Like we'll read database entries that already exist, we'll modify them in some way, and then we'll call save on them. Updation or updating is still constrained with the same validations. And deletion, well, we're going to learn how to delete individual rows or collections of rows in our database table. It's a fairly simple case, right? We either just pinpoint a row or collection of rows and we just say delete these, and then they get removed from the database. So I'm going to stop the screencast and